Okay, I've got a giant mess going over here, so we're going to have to look at some stuff, move it out of the way so that we can get to the main thing for today. The main thing today is I did get the Recreator3D here, and we will attempt to make some PETG filament. I haven't used it in a while, so we'll see how that goes. I did find a water bottle that should work. We'll see. But let's look at some of this other stuff first. So last time, what were we doing last time? I can't even remember now. Let's see. Let me check my notes. Last time, we just talked about different polymers and stuff. But previously, we talked about in topology. Well, it was a recorded lesson, and we talked about the piece of software in topology. So I do have a sample of one of the things. I don't know if, it's a little blurry there. Let's go to this one. Let's go over here. You can see all the mess now. So this is made, it's our vase, the regular vase 57 from Printables at half scale. It's in vase mode. Actually, I don't remember if it's vase mode or layer by layer. I don't remember. I think it is vase mode because of some of the holes we have down here. But it has a hexagon pattern laid over the top of it, and that was done in topology. So if you watched that lecture last week, I think that was last Wednesday, maybe a week ago, then you might have seen, I don't remember if I did this vase in that video or not, but I might have done something like this vase, and it gives you some interesting effect. That isn't the point of in topology, except other than the fact that it makes it possible to overlay these patterns onto other geometry, but it's way more powerful than just that. But I saw this one, and I thought I'd show you that this is one of the things you can do with in topology. So there's that. Let's get it out of the way. Let's see what here's let me find this web page real quick so I can share it correctly. So I think we're on this one. Nope, not that one. Let's get the right one. That one. There we go. So this Toymaker 3D with TOYMAKR 3D.com. If you can't read that. So it's a really cool, they have a lot of free printable models. Most of them are like robot type models. And they actually are pretty well done. A lot of them are free. They do have paid ones also, but a lot of the ones you might be interested in printing are free. These would be good prints for one of the optional assignments on, some of them could be the large model. Some of them could be they're not really compliant. They're actually assembled together. I have a couple of them here. Here's one guy. Oh, wait, we got to go back over here. So here's one guy. So they have articulation. They have like ball and socket joints on them. And you print each color. They're not painted, although I guess you could paint them. Assuming you have all the colors that you need. Since I have all these little these little samples that aren't going to print too many things, I usually use them to print pieces to guys like this. So these are two different Insecticons from a long time ago. Anyway, that would be a interesting assignment for one of your optional assignments. See if I can get these guys out of the way. If you're looking for something a little bit different than the Flexi Dinosaur and the typical stuff that you find on Thingiverse. This is a different site, but it does have free. I think you have to register for the site, so basically you have to have an email. There's no credit card or anything like that, unless you did want to buy. They do have paid models too. They're way more sophisticated than the free ones, but the free ones are actually pretty cool by themselves. So that would be an option if you are interested in printing a little transformer. They don't actually transform, at least none of the ones I've printed actually transform, but they do articulate. So that's interesting. I haven't showed you this one. Let's look at this. It's still over here. So this is one example for FDM printing that it can give you pretty high detail without obvious layer lines. I did show you one guy, a little orc guy, earlier. Well, in case you haven't seen that one, I think he's over here. Let me get him. I never know who's watched what video, but this is the guy that I was talking about. Let's see, get him on the camera. So he's FDM printed. You can kind of tell on the back. If maybe you can't tell on the screen because I can't get it close enough without probably not focusing very well. Yeah, it's not going to focus that close. But in general, you wouldn't really know that he's FDM printed. He is at a smaller layer height, like 0.15 probably, but at a 0.4 nozzle, so I didn't change out to a lower nozzle. Now this printer back here, the one that's you can kind of see running, it is a 0.6 nozzle on that one. That wouldn't work. I don't think you could get a small enough layer to get this kind of detail if you've upsized your nozzle. A point generally, just so you remember, generally your printable layer thicknesses for any given diameter nozzle, the minimum you can go is about 25% of the nozzle diameter layer thickness, and the maximum you can go is about 75%. Now you can tweak things and go outside of those ranges, but in general, those are the sizes that are easy to do without a lot of tweaking. So this guy was just a 0.4 millimeter nozzle with 0.12 or 1.5. I don't remember. I should have written it on there, but I don't remember. But pretty thin layers, and yes, if you knew what you were looking for, you could tell that he was FDM printed. But in general, just looking at him from a distance, you're not going to know that. I've shown this guy before too. This is same deal but bigger. Oh, we're getting our print finished over there. Again, on these guys, if you're trying to print something that has a lot of detail on the front, just tilt it back a little bit, and that'll put any support material you need, unless it's been designed to not need support at all, which some models out there have been, but most haven't. If it's been designed to need support, or it hasn't been considered that, hey, here's the model, do whatever you want with it, then typically if you lean them backwards a little bit and just support the back side, then at least where the support interfaces with the model is going to be hidden, or at least on the back, so it won't be as noticeable. Here's another one. This one's actually made for resin printing, but it's FDM. You can definitely see on the bottom, there's all kinds of layer lines on the bottom. This one, I believe I did print with a larger 0.6 millimeter nozzle, but at 0.2 layer thickness, and you still get quite a bit of detail out of it. Now it's been painted, it didn't print in color. What you can do is you can spray these things, if they're larger, like this guy, spray them with automotive primer, which is usually thicker. And if you get it not so thick that it's obscuring all your detail, but thick enough that it kind of hides the layer lines, then yes, again, you can pick out some places where the layer lines are more obvious, but they're not that bad for FDM printed. This is actually two pieces. He joins right here and actually, right there, so like right in those regions. So that top part is separate from that bottom part, so that saves a lot of the support on this guy. And I think there is an option to print him in two or in one piece, but then you would have support in like touching here up to another piece, and that's generally not good. If you want to use support, it's a lot better if you can get away with just supporting one side of the model, like the other part of the support is on the bed. That's generally going to be easier to remove than if the support has to build on top of the model, go up and support something other part of the model. That's kind of hard to remove a lot of times. Well, since this finished, we can look at it. All this is the that antibacterial PLA. I don't see the, oh, here it is. Antibacterial PLA from last time on Monday. I just printed a vase in it because I didn't have one. It's a nice color too. And seems like it printed well. I did have a failure on this print. Actually, I had two failures in a row. I was printing material. Here you can kind of see a piece of the Recreator over here. I was printing, I was printing the vase material, you know, reclaimed material. I think my camera might have froze there. Let me see if I can get it back. We'll see, sometimes it'll come back and other times it did come back, it's just upside down. All right. So yeah, now we're back live. So I just printed some of this, but the failure had nothing to do with the material, either one, the reclaimed material or this antibacterial. The failure was actually, well, it froze again on me. So the nozzle, remember we changed out, well, we changed out a lot of things on this particular one. We changed out the whole hot end. On this printer, the hot end is one of the Slice Engineering direct drive hot ends, and in part of doing that, I had to print a different mounting part here. I don't think that's the problem, although this particular one doesn't seem to cool the cold side of the hot end very well. It kind of does, but it's not aimed right at it, and so I think we're getting a little bit of heat creep. But the actual problem was that nozzle. It has a hardened steel nozzle in there, and I never did get it heat set. What that means is when you replace a nozzle, you tighten it up, and you use a little wrench or whatever to get it kind of tight, but not over tight. Then you heat up the hot end to 200 Celsius or so, and you tighten it another, you know, eighth of a turn or something. You know, you tighten it more. And I never did get that effectively done because I was just using the little flat wrenches that come with the kit, and those are not very well. For one thing, they're super thin, and they get hot when they're on the nozzle. They get hot in 5 seconds or something, to where you can't hold them. And so I didn't get it really tightened well. And what that does is that means that there's potentially a little bit of a gap between where the nozzle ends and the heat break comes in and touches. So the nozzle is supposed to touch the heat break, and if you don't get that extra little bit in there, you might have a super tiny gap between those two, and filament will come out the sides, and you'll get clogs. That's what I was having happen. So I went and grabbed one of the wrenches that I have, a tiny little wrench that will fit the nozzle, and reheat set it, and so far printed without any problem. This actually looks pretty good. I don't see any real issues with that. So hopefully we fixed our heat creep issue. What else do I have up here? I'm getting this all out of the way so that we can look at the Recreator. Oh, I did order something interesting, or at least it looks interesting. We'll see. It should be here. Won't be in here it'll be next week before we can look at it. But now that we have the bed sensor on here, we're not so concerned about the height of our bed, right? So if you don't have a bed sensor, then anytime you change anything about the surface here, the thickness, you know, put something thicker, put something on top, or remove the glass and put something under, you know, print underneath that or whatever. If they're different thicknesses, then you have to go reset your Z height, because it's all triggered off of a little switch that's not on mine anymore, but would be over here. And so that's a pain. But now that we have our bed sensor on here, the probe is going to determine where the bed's at. Then we're not so worried about taking this glass off and putting some other surface on. So I ordered, let's see if I can find it. And this is I haven't used one of these before, so I don't know how well it's going to go. But let's order this. So this is one. It's showing 2 sheets, but it's actually just one that's double-sided. So it's not actually 2 sheets. But one sheet, the coppery gold one in the background, I guess it's more gold than copper, is actually PEI. So PEI is a material that is common to print on because it will bond to your print. So as you're printing it, if you heat it up, if you use a heated bed, then it will bond to the print and hold it firm while you're printing. So if you're having adhesion problems, then that's one way to deal with it. I've seen these PEI sheets warp because they won't let go of the part. So I was printing a larger ABS part that I thought would warp anyway, but I tried to, I put it on the PEI sheet to see if it would stick down. Instead of it pulling away from the PEI sheet, it pulled the PEI sheet away from the printer. So I didn't have the PEI sheet attached well enough to the printer. So it will grab onto material. Then you just have to make sure it stays in place. But that's pretty ordinary. Your printer may have come with a PEI sheet on it. Usually unless you get one of the higher end, I don't think the Creality ship with any PEI sheet. But the other sheet here, this one here, this is PEO. So it's the polyethylene. I think it's a high density polyethylene or something. It will also grab to your part. It doesn't work like PEI in the same way, I don't believe. What it does do, though, is this pattern. So all these little triangles. This pattern will be not, I don't want to say embossed because it's not a raised texture, but it will be transferred to the bottom, whatever surface your part is touching this pattern. That pattern will be transferred to it. So it gives you some really cool effects on, at least on that surface where it's touching the sheet. So I'm going to try that. This is a magnetic bed. I think this one actually comes, does this one come with the magnet? Yes, so some of these do come with a magnet. It says with magnetic base, and others do not. This is actually not specifically made for a Ender 3. It's artillery and ANET printers. But it's 220 by 220 millimeters, so that should fit on our bed over here, which is 225, I think. So it should fit on there. It might be a little bit smaller than what we have on here, but that's fine. As long as it fits on there and doesn't overhang anything and crash, then we should be okay. There is a 235 one, but I think that's a little too big. I didn't actually measure. I was just going off what I remembered. So I ordered this guy, and it'll be here. Well, it's, I don't know, probably not in time. It probably won't be here tomorrow so that we can use it Friday. But hopefully on Monday we'll have some results from that. In the meantime, I am going to put a magnetic, I'm not going to use the magnet that comes with this kit. Usually these magnets are, it didn't show it. Well, it kind of shows it there. These magnets are basically giant refrigerator magnets that you stick down to the printer, and they work fine. But I do have a different one that I'm going to use. I have this one. Let's see if our camera's still working or if it's locked up again. Oh, it's working. I have this one. That's actually not the magnet. This is not the magnet. Let me get the magnet out. Oh no, this one does have. Okay. This is a build tack. Some people don't like build tack. That's fine. It is a surface. It's also, I think it's also PEO. It's just not patterned in any way. But it's a magnetic sheet here. So, and it's, instead of being a refrigerator magnet like one whole sheet, it is individual magnets placed in this, in this pattern here. It does stick down, so it will have to be stuck onto our bed. I'm not going to stick it on the glass. I'm going to, well, let's get this off of here. Now that I'm going to remove the glass, put our sticky stuff down, and then we'll have a magnetic bed on here. And the downside will be now the heated surface, this guy, is going to have to heat through more stuff. So if I put magnetic bed, and glass, then there's a lot of insulator type material that the heated surface is going to have to go through. So these beds can typically get up to around 80, maybe 85 degrees Celsius. I don't normally print many things that have to be that hot for the bed. So I think we'll be okay, but it will mean that I probably have to raise my bed temperature just because I'm trying to conduct heat through more stuff than I was before. Just make sure this is gonna, yeah, that's gonna go right there. All right, I'm gonna clean it off. So if you ever get one of these, if your printer didn't come with a magnetic bed, it's really straightforward. You take off whatever's there, clean this surface because you have to adhere the magnetic sheet to it. And if you do get one, most of them do have that refrigerator magnet stuff. It works fine. I will say that is the kind that pulled away the PEI sheet that I was talking about earlier. It did pull away from one of those. The next I did print again, and I just used some of these clip type things to hold it down, and it was okay. So the magnet wasn't enough on its own. So there's that. And then we're going to pull this guy off and stick it down. It's actually kind of hard to remove the film. You can get these things off of here if you need to take them off for some reason, but they are not reusable. I've never been able to take one off and then reuse it. And you can use a magnetic bed without the magnet. You can just hold it down with the clips, and you maybe just want the PEI surface. Some of the PEI surfaces are textured. This particular one is smooth, but I think I actually have some textured ones in there. They also give you a cool effect because instead of just a pattern, they actually have surface relief. So they have a texture to them that you can feel. And then your parts that you print on there will also have that. They'll also have that pattern made into them. So now we have a magnetic bed. We can still use our glass if we want to. It's obviously not magnetic, so we have to clip it down. I don't know that these little clips are going to be wide enough now. Yeah, but I have others. I have these. I don't remember where I got these off of Amazon. I don't even remember what they're called, but these little guys, I like these because they will grab, and they only, well, I'll show you if I can get it to all work here. All that pokes up is that little knob right there, so it doesn't really intrude on your printing area anywhere. And so these, I'll see if I can find the link. I don't know what they're called, but they're these kind of bed clips. They work really well, and they don't obscure a lot of your printing area. And they're adjustable, you know, well, they're springy, so they can do different thicknesses of stuff. If you're changing out bed materials and they're not magnetic, then these are pretty handy. All right, so but now since it is magnetic, we can just, you know, put down whatever. This one's very greasy looking, but we can just put down whatever surface we want. And since we have the bed probe on there, we don't have to worry about adjusting the end stop for changing heights because not all these are the same thickness. So that's a nice little upgrade. I might clean that off and try printing on it. I don't know what we'll print, but actually I'll probably have to move this printer out of the way so that we can get to the Recreator. But let's see if we can get this looking a little better. This one is just a PEI non-textured, so it's smooth. So stuff that comes off of this will have a smooth surface on the bottom of it. So you can clean PEI with these isopropyl alcohol pads, but don't clean them with acetone. The PEI will react with acetone, and then you'll not have a PEI sheet, or at least not a good one. All right. So that's an easy change, and I think it is an upgrade. If your printer just came with maybe just the rubbery sheet, then I think this is an upgrade for most printers like that. For one, it's easy to change out the sheets. for another, it's easy to get the parts off of there. So one of the main purposes of these spring steel sheets is that you pull it off and then you can just snap the part off. So you don't have to do the scraping. In fact, you really don't want to scrape on the PEI sheet unless you just really had to, because you're probably going to scratch up the PEI surface. I'm looking at this one and it doesn't look like PEI, so I'm not 100% sure that this is a PEI surface. Normally PEI has a goldish tint to it, greenish gold tint, and this one really doesn't, so I might have to investigate what type surface. This could just be a spring steel sheet, I don't know. But it's from Build-Tac Flex Plate, and I've had it sitting in a closet for a long time, so I'm going to try it out. Alright, any other things? I think we've got all of our little show and tell out of the way. Let's see if we can move over to the Recreator. So I've got to make some room. In fact, I'm going to move this printer out of the way because I need to get the other thing in the camera. So let's just set it on the floor. Okay. Oh, there's another thing. So this little guy is, if you ever watch YouTube and watch Chuck Hellebuck, he made these. They're really super simple. There's a CR 2032 coin cell battery and a momentary switch and a LED with a resistor so you don't burn out the LED. That's all they are. And a printed part here. What they do is, this is, I think he calls it the E-leveler. There it is. He calls it the E-leveler. And you can get them off of Amazon. There's a bunch of fake ones out there too that I've seen, but his are the Filament Friday brand, or Chip is his like YouTube name. But what you do is you put it under the nozzle, and when your nozzle would be aimed at this little crosshairs, and when your nozzle barely touches it, then the LED comes on, and you can use it if you're not comfortable using just looking at it, eyeballing it, or if the paper, dragging the paper under the nozzle doesn't make sense on, how much drag are you supposed to have between the nozzle and the bed, then this gives you a visual indicator. So it's used for leveling your bed. Leveling meaning more like tramming, but it's used for that. They're like $10 or something. I thought I'd pick one up and try it out. It does work. And I didn't have any problems with it, so it's pretty neat. All right, let's see. Let's get the Recreator. Oh wait, this is our Sonic pad. We don't need that right now. See if we can get it out of the way because it is wrapped around everything. All right, stuff's falling, but that's okay. So this. Oh wow. I don't know if I can. There we go. There's all of it. This is the Recreator3D. So it's basically mostly printed. So the gray and black parts, except for these are not gray. These gray parts are not printed. Gray and black parts are all printed, and then the hardware is hardware from an Ender 3. Now these particular pieces did not come off of Ender 3. They could have, but they did not. These could have been the uprights for an Ender 3, but we had these pieces around, so we used those. A student built this. It's actually, well, they didn't design it. So Recreator3D.com here is the, let's see if we can go to, that's actually Philibot, that's not them. Here they are, Recreator3D.com. All the files are here. I believe they are free files. I don't remember if they're on printables or where exactly you get them, but you can print. He's got several versions of these. There's a smaller version. Let's see. I think this is the smaller one. Well, it doesn't have many pictures here, but this is the one that we printed. There's the SD. Yeah, they're on printables. The files are on printables. So if you have an old Ender 3 and you have a printer that can print, so if you use the Ender 3, it's going to be taken apart, so you won't be able to print with it anymore. But I suppose you could print the parts, then take the Ender apart and have a Recreator, but you wouldn't have a printer anymore. So you almost need an extra Ender 3, and it doesn't have to be an Ender 3. There are other similar printers that could work, but you might end up having to modify mounting holes and things like that. So it's definitely made, or at least this kit is definitely made to repurpose an older Ender 3 into a filament reclaimer. Well, I guess I shouldn't say that. It doesn't reclaim filament. It creates filament from plastic waste, particularly soda bottles. So let's go back to ours. So you can see here's the hot end from an Ender 3. Got the screen from one. This is the Z-axis over here. Z-axis for one. What other pieces? Well, these rails would be from an Ender 3. The power supply is down. You can kind of see the top of it there. That's from an old Ender 3. Layer cooling fan is now the filament cooling fan. And then everything else is printed. Now there are hardware like screws and nuts. I don't know if he's designed it in a way to where you could use only hardware from the Ender 3 to mount it all together, or if you would have to get some other screws. We had plenty, so we didn't bother with that. But this was one of the students' special topics class. So they took these files, printed them all, got it working, and they did make some filament. So here's some of the filament that they actually made. It's what it might look like. This is maybe their first sample, so it's kind of corkscrewy. But they did make enough that I was able to print part of a vase. Now this is the vase that I think it was going to run out of filament anyway. It was getting really low. We never made a ton of filament with this, or at least I didn't have a ton of filament from this, but it was printing fine. Now it does have, you'll notice some orange stripes in there. So anything that's in the filament, so if it has a marking on it, maybe the bottle has a date stamp or whatever, anything that you leave on the film, on the bottle, so you can kind of see here's our little bottle right here, turning into strips, and the strips are hopefully going to turn into filament. Anything that you leave on there is going to show up in your print. So it gave you some little zebra stripe type things. It did give me the idea that when I was trying to do this, so I was trying to dye PLA for our Rook 2020 printer. This is PETG, so at least most of your bottles and things like that are PETG, the soda and water bottle type things. It did give me the idea that maybe I could dye the filament before I print with it, because PETG has a much higher glass transition temperature, so I can get it hotter than I could get the PLA, which was one of the reasons why I did get some dye to work, because those originally were the same color and now they're at least different colors, you can tell, but I couldn't get it hot enough without damaging the PLA part. So I might be able to dye the filament. So I'm going to try that and see how that works. It prints fine. It prints well. All right. One exception. It does seem like this repurposed PETG from these bottles, these type bottles, prints much hotter than what you can print PETG with from Amazon. So Amazon or wherever online retailer that you get PETG, you can print that at sometimes 220, certainly 230 Celsius, which is fine for an Ender 3. This stuff I did have to print at 265, so that will not work on an Ender 3 that hasn't been modified. So our Ender 3 has been modified with an all metal hot end, so it can go up to actually 290, I think is what I have it set as the max on it. But if you tried to print this particular material on a regular stock Ender 3, I don't think it would print, because the most you can really go on those is 240. You might get up to 245, and it just wasn't melting at that temperature. It just wasn't. So do be aware that it seems like, at least for the stuff I've reclaimed, you have to be much hotter than what you normally are. And it's hotter to the point that it's not going to print long on a Ender 3 that hasn't been modified some way. So make sure you know that before you go build one of these things, make all your filament, and then you can't print it on a regular Ender 3. It does need a printer. At least I'm going to say it does need a printer that's going to be able to print hotter temperatures. So an all metal hot end. Now you can add all metal hot end to an Ender 3. That's what we did. We added a Slice Engineering direct drive one, but there are much cheaper ones. You could just get the heat break that's all metal and replace that and be fine, I think. All right, so let's see if we can get this thing on and doing something. So, oh, it's already plugged in. Nope, it's plugged in, but there's no power on that. So let's switch it out with this one. Okay, so comes on. It has a one printing file on here that is going to basically heat up our extruder and start running our spooler. Now I think he's changed up this part a little bit, even on the design like this one. I'm not going to worry too much about that, but I've already started, stripping one of these just because this particular bottle had a lot of texture. Well, it wasn't this kind, but it had this kind of texture on it, and that was hard to pull through here, so I had to manually pull it through. So let's go ahead and heat it up. Let's heat our nozzle to 200. You'll notice on our, let's see if I go to our info screen, I don't know if you can tell it or not, but the bed temperature here, there's no bed probe connected, so it says it's -14. If you ever get some weird readings like that, that means that there's something wrong with your thermistor. In this case, it just doesn't exist because it's not there. Oh, that's another part that this machine does use. It uses the board out of an Ender 3, so it does use that also. So basically, by the time you've built one of these, whatever Ender 3 you took the parts from, there's not a lot. There's a few pieces of extrusion left, and the bed, the V wheel, stuff like that. But there's not anything usable electronic wise. It's all over here. All right. So what I've done is I've kind of made a point here. And you have to, so this does not extrude. There's nothing pushing filament. It pull-trudes. So I've got to manually feed the filament out here and then wrap it around this guy so it pulls the filament through. And as it's pulling that, hopefully, you can see, this is geared down to where it's generating a decent amount of torque. So hopefully it will pull and slice our bottle at the same time. I don't think it would have done that at the beginning because I did not go through and remove all of the bumps. You can kind of even see some of them in there. And it was having a hard time actually slicing it. What you're supposed to do, and this is a really small bottle. It's just a water bottle, but normally you use a 2 liter. And some 2 liters just have smooth sides already, so you just use those. But a lot of times they have some kind of texturing just for design reasons, not really for any other reason, and you need to remove as much of that as possible. So you can make one of these, not with an Ender 3. This is just a valve stem from a tire. You can get those from any automotive store or whatever, and you put it in a cap, and then you inflate the bottle. So you add some air here, inflate. These are, well, the water bottles are not normally pressurized, not very much anyway, just static, hydrostatic pressure, I guess. But the soda bottles actually have a decent amount of pressure inside them. So you pressurize them, and then heat it like with a heat gun or hot water and try to remove some of this texturing. I did not do that on this one. It didn't have a lot, and this section is actually already smooth, so I didn't do that. And so I was having trouble getting the little strand of pre-filament to slice. You do have to size this, so you're trying to make, at least I'm trying to make 1.75 millimeter diameter filament, which is what all of my printers use here. And so you have to size this so that its cross-sectional area is the same, or at least close to a 1.75 millimeter diameter circle. So 1.75 squared times pi divided by 4 is like 2.4 square millimeters. So you have to measure your thickness of your sidewall and then make your strip a width that gives you around 2.4 square millimeters of cross section. I'm actually undersized because well, I just am. So we'll see if that it's going to make slightly smaller diameter filament, and I think that's actually okay. If I have under extrusion issues, then I can increase my flow multiplier. So, oh, the other thing is this nozzle has been drilled out to 1.75 millimeters. I think I'm going to re-drill it though, or make a new one, because I'm getting filament that looks more or less right, but it is a little bit rough, and I think there's a burr inside there. Let me get something to grab this with. It's going to be hot, so I can't just grab it with my hands. Let's see if we can get it to start in there. Having issues, I may have to pull it this way. And I might need a little bit sharper of a point here. So it'll almost just slide through the nozzle. Getting everything lined up is a little bit tricky. There we go. All right, so you can kind of see it coming out of our nozzle there, sort of. I might have to heat it up a little bit more. Yeah, I think I gotta go a little hotter. Let's go up to actually, so I don't know what this is set at as far as the maximum in the firmware, what the maximum temperature setting is, but I don't actually have the issue of I do have an all metal hot end because there's no heat break there's no Bowden tube at all in there. There's a heat break, but there's no Bowden tube in there, so I don't have to worry about burning up my Bowden tube. Oh, we had a tear out. Might have to, it was starting. It might be a little finicky to get going. And it might be that we can't get it going at all. We'll see. I might have to go a little hotter. Like I said, I was having to print this stuff at 260, which I'm nowhere near right now. Look, started out and then it came back in on me. Oh, it curled up. So what this can't do is it doesn't create filament from just any material, right? So the way filament, we talked about how filament is made last time, where you take pellets and extrude them. Not the same way that your extruder works. A screw extruder is how that machine would work, which is similar. If you've ever seen a big drill bit, it's similar to that, but it's designed quite different. Can't get it to start out in our hole there. Ooh, it is warm. Just doesn't want to. Kind of need to straighten it out a little bit. Well, it's just can't get the right size that it'll start. Either have it too thin or too thick. Well, let's see. Might need to clear out my nozzle there. That's right in the way. There we go. I think I've got a little block of, there we go. I had a little burned up piece that was blocking everything. So let's try again. If we can't get it soon, I'll just I'll work on it offline and we'll look at it Friday, actually making some filament. But I'd like to get it started. We had it going and then it just probably wasn't hot enough to extrude the, or to melt the stuff. It's definitely melting it. I don't want it to become like molten. I just need it to soften up enough that I can pull it through. Let's see. I might have to do this a different way. Let's see. Actually, let's clear it out. Alright, because I think what's happening is that I've already got it heated and it's melting it and curling it up as soon as I try to pull it out. So I'm going to actually turn this off and see if we can just get it fed in there while it's cold enough that we can start actually making the filament we want to make. While it's cooling down, let me prepare this strip a little better, because we're going to need a long strip. All right, so it's still cooling down though, but let's look, since we've got it pulled up here, the other way, like the more industrial way, although this is still I don't know if this is consumer level, because we're talking $20,000 here, so not consumer level, but actually this one with the nicer one is $30,000. So this is how filament would be made from the pellets. Now this has got the whole system here. So this is Filabot, filabot.com, and they have a filament reclaimer. So say you want to take your prints that didn't work out, your support material, stuff like that. This box at the back, I don't know if I can make this much bigger. Oh yeah, I can. Great. Except my picture's in the way. Let's move me down there. All right, so this reclaimer in the back, it is chopper. It's going to chop up filament into pellet size that can go into the hopper here, or can feed into this little guy. So this is the one we have, is the small one, but they do have a much nicer, bigger one. These are both screw extruders, so they have in this chamber in here, they have a what looks like a really big giant screw, except it's specially made with a taper and everything, so that it will mix and heat. There's also a heater in here, but it was just the friction of compressing the pellets will also heat them. The pellets, so that they come out of these dies. So these dies can be set to whatever shape and the diameter you want. I think what they have are the 3mm and the 1.75mm circles, which are the most common. Goes over a cooling path, a take-up reel, and then if you have a bad diameter, this take-up reel will actually monitor diameter and everything as it's taking up the filament. So if you get some that's oversized or way undersized, then they've got this guy that takes that filament that didn't get used because it's got a problem. You know, it's the wrong color, it's the wrong diameter, some reason you're not using that filament, and chop it back into little pellets that can go back in the hopper and make more filament. So that is basically the same way it would work in industry, only in the industry these are even bigger machines, but even this one, you know, $30,000 is not something you're just going to go and buy. Looks like we've cooled off over here, so let's see if now we have any better luck loading this guy while it's not going to melt the filament that not going to melt the strip as I'm trying to put it in. Ah, there, we got it. All right. All right, so we've got some, oh, turned around where you can't see. All right, so we've got some coming out. Let's heat up our nozzle. But let's go pretty hot because I was having trouble even at 220. So let's go to 230, which I don't know if I want to go all the way to 260. Let's go to 230 for now. And see if we can get that. We don't need to print this filament, we just need to melt it. Basically this strip is going to fold over itself and create, hopefully, a little piece of filament that we can use. Now the amount we have here is not going to create a lot. Normally you use a whole 2 liter. I think they said on the Recreator site, let's see if I can find it. Let's see, I don't remember where in the operations manual, I believe. Let's see. All right, so 40 bottles, I assume those are 2 liter bottles, will make you a kilogram of PETG. And you know that most of these bottles you're not going to go buy them or anything, you're just going to have them, or I don't know if you're, we know how long it'll take you to get 40 bottles, but might take a while. But if you're just collecting them somehow, or somebody's giving you their bottles, obviously more of these bottles will be needed than the 2 liters. But based on this guy's pricing, you know, of trying to buy the bottles, then it will cost $2 to make a kilogram of PETG. So that's a pretty decent price to work with. Now that's not including all of this price. So you did sacrifice a printer and all of that to get to there. I still feel like we're having to pull a little too hard. I'm going to go hotter. We should need to, you know, have some amount of force because pulling it is also going to size it. But I don't want to do it like last time where I broke it in half pulling on it. So, and I feel like it's still a little bit too difficult to pull through there. So now I'm at 240. I'm going to 240. Yeah, it's just too much, I think. I'm going to go hotter. Go up to 250. Now again, on a regular Ender 3 that has the Bowden tube down in the hot end, 250 is too hot. In fact, I don't even know if it'll let you go that high without modifying the firmware. Let's see where we're at. Oh wow, now we're like oozing out. Oh, I think it, all right, well, I may have to get it set up off camera. It's not folding over correctly. That's a bit of our problem. And it's getting hung in here, not at the nozzle, it's getting hung in here. But we actually were way hotter than we needed to be. So I think what I'll do is I'll tweak it, get it set up to where I'll have it already spooling, and then next time we can just watch it spool a little bit, because I'm having issues in here right now that are making it a little difficult to get our filament to actually extrude or pull-trude. So I'll get that set up, and we'll do that. We're pretty close to the end today anyway. I don't think our new sheet will be available to use Friday, but we'll have that. I don't know exactly what we'll do on Friday. We'll do this, but I don't know what else we'll do. If you have any ideas of what you want to see, let me know. Otherwise, I'll generate my own ideas. All right, I will see y'all on Friday. We'll come back to this guy. I don't want to just sit here and fiddle with it while we might get it working. I will eventually get it working. It's just it's going to take a little bit of maneuvering to get it to do what I want it to do. All right, I will see y'all.